Atom is a basic building blocks of matter that make up everyday objects. An atom is really, really small. You cannot see it with your bare eyes. All elements are made up of atoms. Everything are made up of atoms, including chair, desk, air, or even you are made up of atoms. Atoms are made up of protons with a positive charge, neutrons with a neutral charge, and electrons with a negative charge. The nucleus of an atom consists of neutrons with a neutral charge and proton with a positive charge. So basically the nucleus has a positive charge. This picture, the blue and the red balls are the nucleus of the atom, so it is the neutron and the proton. And the electron are moving around the nucleus in the circular paths called orbit, shells, or energy level.
Isotopes. Isotopes are different versions of element or atoms that have the same number of protons and electrons, but a different number of neutrons. Changing the number of neutrons does not change the type of the element. However, it changes the mass number because mass is proton plus neutron. So if you change the number of neutron, it will change the mass of the element. I have an example here of isotopes of hydrogen. There are 3 types of hydrogen, which is the first one is hydrogen with 1 proton and 1 electron. The second type is deuterium with 1 proton, 1 electron, and 1 neutron. The third one is tritium with 1 proton, 1 electron, and 2 neutrons. So there are 3 types of hydrogen. The 3 types have the same number of electrons and the same number of protons, but the number of neutrons are different, and they are called the isotopes of hydrogen. So this is an example of isotopes, which are 3 types of carbon. So the first one is carbon-12 with 6 protons and 6 neutrons. Second one is carbon-13 with 6 protons and 7 neutrons. And the third one is carbon-14 with 6 protons and 8 neutrons. As you can see here, all of the carbon have 6 protons, but they have different number of neutrons, which are 6, 7, and 8. You can see the pattern here that 6 protons plus 6 neutrons equals to 12, which is carbon-12, and then 6 plus 7 equals to 13, which is carbon-13, and then 6 protons plus 8 neutrons equals to 14, which is carbon-14. So that it proves that if the number of neutrons change, the number of mass also change. Quantum numbers. Quantum numbers tell us 4 things, which are the distance from the nucleus, the shape of the orbital, the position of the orbital, and the spin of electron. There are 4 quantum numbers. The first one is the principal quantum numbers, which is small letter n, and then angular momentum quantum number, which is small letter l, and then magnetic quantum number, which is ml, and then spin quantum number, which is ms. Now there are rules before we begin. The first rule is the Aufbau principle, and it tells us to build up, or to fill the electrons from the lowest available orbit and slowly start putting electrons to the higher and higher energy orbitals. The second one is Hund's principle, and it tells when you have more than one same sub-energy orbital, you put electron into each orbital, and once each orbital have 1 electron, you can go back and start doubling them up. So 1 orbital here, the box is representing 1 orbit, and it can have a maximum number of 2 electrons. Now, if you have 3 electrons to put into the orbit, you cannot put up, down, and then up, but you have to go up, up, up until all orbitals have 1 electron, and then you go back and fill it until it has the number of electrons. The third one is the Pauli exclusion principle, and it tells that no 2 electrons can have the same exact address. They will always have different principal energy level, different magnetic quantum number, spin, and the angular momentum to ensure that there are no 2 electrons are located in the same space. So the first one is the principal quantum numbers, or the small n. It describes the main energy level or the distance from the nucleus. The energy level is 1, 2, 3, 4, and so on. I have an example here. It's 2p6. So the n, or the principal quantum number, is 2. You just have to look at the first digit here. If it's 2, so the n is 2. And then second example is 4f8. So the n equals to 4. And then 6d10. So n equals to 6. Second one is the angular momentum quantum number, or the small n. Describes the shape or type of orbital. There are 4 types of angular momentum quantum number, which are s equals to 0, p equals to 1, d equals to 2, and f equals to 3. You just have to look at the sub-levels, and each sub-levels has each digit here. For example, you have 2p6. You should look at the p, and then the p equals to 1. So L equals to 1. Next example is 4f8. You look at the f, and then here f equals to 3. So angular momentum quantum number, or the L, equals to 3. Next example is 6d10. D equals to 2, so L equals to 2. And then 1s1, S equals to 1. X equals to 0. So L equals to, supposed to be 0. Next is the magnetic quantum number, or the ML. Describes the electron's position in the orbital. S has 1 possible position, P has 3 possible position, D have 5 possible position, and F has 7 possible position. So there's this picture here. The S has 1 possible position, so the ML of S is 0 because it's only 1. And then P has 3, so it can be negative 1, 0, or 1. And then D have 5, so it can be negative 2, negative 1, 0, 1, or 2. And then F can be negative 3, negative 2, negative 1, 0, 1, 2, or 3. The next one is the spin, or MS. It describes the electron spin. There are only 2 possible answers, which are plus 1 over 2, or counterclockwise, or negative 1 over 2, or clockwise. I have this example here. So if the arrow is going up, so the MS is equals to positive 1 over 2. But for example, your arrow stops here, so then it faces down, so then the MS equals to negative 1 over 2. Electronic configuration is the distribution of electrons or specific address of an electron in various shells or energy levels in an atom. formula which represents the maximum number of electrons in each energy level of an atom is 2n squared, which n represents the energy level. So if you want to see how many electrons are there in energy level 1, you can count by 2 times 1 squared equals to 2. And the second energy level is 2 times 2 squared, which is 8. The third energy level is 2 times 3 squared, which is 18. And for the fourth energy level is 2 times 4 squared, which is 32, and so on. I have here my periodic table, and I want to show you how to get the electronic configuration from the periodic table. First, I have this 6 label here, D label here, P, and then F. And if I want to count the hydrogen, electronic configuration of hydrogen is located in the S part here, and it is in the first row. So it is 1. So hydrogen is 1, and then it's in the S row, S, and then it is in the first here. So it's 1 S1. And then the second example is if you want to count for the electronic configuration of carbon, you should pass hydrogen and helium in the first row. So carbon, you start with 1, and then it's in the S here, so 1s2, and then you should pass this 2 here, so it will give me 2s2, and then you move here to the P part, and you should pass this, which is 2p2. So the total electronic configuration of carbon is 1s2, 2s2, and 2p2. Now, if you want to know the electronic configuration of, for example, sodium, first you should pass hydrogen and helium, which is in the first row and in the S part, so 1s2, and then pass lithium, beryllium in the second row in the S part, so 2s2, and then pass here boron, carbon, nitrogen, oxygen, fluorine, and neon in the second row, and then in the P part, and 6 elements, which gives me 2p6. And then you will go back here to find sodium, and it is in the third row, the S part, and it is in the first line. So the electronic configuration of sodium is 1s2, 2s2, 2p6, and 3s1. Now this is another way to find electronic configuration of element. First, you start here, 1s, and then go down 2s, then go up here, follow the arrow, 2p, go down, 3s, go up 3p, and then go down 4s, and then go up 3d, go down 4p, and 5s, and so on and so on. You just follow the direction of the arrow.